Hello, this is day 2 of our solving unit, solving with multiplication and division. The solving steps for multiplication and division fit into the solving steps that we learned yesterday. And if you want to see the solving steps completely written out, you'll need to check the notes from yesterday for the complete version. But for the simplified version, the solving steps start with a simplify step. This is the longest step because there's all kinds of things we can simplify. After simplifying both sides of the equation, you're going to add or subtract terms to get the x's left and the numbers right. And by left and right, I mean of the equal sign. Today's notes are for solving problems that start after step 2. So the ones we're going to be dealing with today are going to involve multiplication. The third step in solving is to multiply by the reciprocal to get a 1x equals, and when you have a 1x on the left, it is always equal to the answer. So all solving steps are designed to get you to a positive 1x. The fourth step, which we won't be doing today, is the checking step. We will practice that at a later time. All right, so our first example is a very simple one. Negative 4x equals negative 16. Draw the line down the middle so you don't forget where the equal sign is. So obviously x is 4, but the point is not the answer, it's getting to it using a solving process. So going through our steps, there's nothing to simplify on the left or the right. All the x's are left, all the numbers are right. So steps 1 and 2 are done. So we're ready for step 3, which is multiply by the reciprocal. So when you're doing reciprocal, put all whole numbers over their invisible one. And we are going to multiply the x term by its reciprocal, which is when you flip the number 1 over negative 4, and which means we have to multiply by the reciprocal of the right, 1 over negative 4. The wonderful quality of reciprocals is when you multiply them, everything divides to a 1, which gives us our 1x. On the right, you just simplify. A negative divided by negative is a positive. 16 divided by 4 is 4. And you have your answer. And it's your choice if you want the 1x or just put an x. Either one. All right, that was an extremely simple example. Let's go to one that's a little more complicated. So leave a little space. 3x over negative 7 equals 4. The nice thing about reciprocals is it makes something that looks really complicated quite simple. Again, our first two steps on solving are taken care of. Everything is simplified. The x term is on the left. The number term is on the right. So we're ready to go straight to step 3, multiply by the reciprocal to get a 1x. So put the 4 over its invisible 1, and the reciprocal of 3 over negative 7 is negative 7 over 3. And we're going to multiply both sides by the same thing because we need to keep the sides equal. On the left, the reciprocal multiplies and simplifies to a 1x. On the right, we have negative 28 over 3, and we're done. See how easy that was? Reciprocals make fractions really simple. All right, third example. This is a 5/8 with an x on the side equals a negative absolute value of 5. Put your line down the middle. Now, I picked this one because on our last test, we struggled a bit with simplifying this right-hand side. So we're going to do a really quick remediation on that. Anytime you have a negative in front of a grouping symbol, like an absolute value bar, it means there is a negative 1 being multiplied by the absolute value of 5. So when you do your first step, which is to simplify the absolute value of 5, the negative 1 is not affected because it's the scalar in the front. Well, the absolute value of 5 is 5. So you have negative 1 times 5, which is negative 5. What happened on the last test was students thought this negative was inside the absolute value bars. So when they simplified the 5, they treated it like a negative 5, and the negative just went away, when in reality, it's not inside the bars at all. Okay, so our left side has not changed. It's 5/8 times x. You can just draw a little arrow there. And again, we've simplified. Add or subtract, x's are already left. Add or subtract, numbers are already right. So we're ready for step 3. Multiply by the reciprocal to get x alone. So put your negative 5 over a 1. And the reciprocal of 5/8 is 8/5. We're going to multiply both sides by 8/5. On the left, when you multiply reciprocals, they divide to 1, so we have a 1x. On the right, there's actually several ways you can simplify it. I would do whichever way you are most comfortable with. When I look at this, with the two fractions being multiplied, what I actually see is a negative with a 5 times an 8 on the top and a 5 on the bottom. So in my mind, I'm multiplying the tops and multiplying the bottoms, and I know I can divide a 5 out of the top and the bottom. So you can factor it like this, or if you can envision it being multiplied, you can divide the 5s out there. Just don't lose the negative. So a negative 1 times an 8 is a negative 8. You have your answer. Another way to do this is to go ahead and multiply. Negative 5 times 8 is negative 40. 1 times 5 is 5. And then just simplify it from there to get the answer. So you choose which way you like the best. All right, I'm going to teach you another shortcut today. Like all shortcuts, if you don't like it, don't use it. So example 4 is 5/9 equals negative x over 7. Now, without the shortcut, you would need to add or subtract the x term left, add or subtract the number term to the right, and then you would accomplish getting x's left and numbers right. Here is the shortcut. If all your x's are on the right and none of them are on the left, you can use a property called reflexive property, which is one we're going to see time and time again, which says you can switch sides without changing the numbers, and it is equivalent to the original expression. So switching sides, I have negative x over 7 equals 5/9. Notice none of the numbers have changed. The signs are still attached. But look how you saved some time. In one step, the x's are left, the numbers are right, and you're ready to move on. If you don't like doing this, then do it the normal way, which is to subtract x terms left and subtract number terms right. All right, the other part of this that sometimes I get questions on is, what do I do for the reciprocal? Remember that the negative x is really a negative 1x. So if you write the 1, you're more likely to see that the reciprocal is 7/1, which we do on the right, 7/1. The reciprocals cancel out. I have a 1x. And on the right, a positive divided by a negative is a negative. And a positive times a negative is a negative. 35/9. Make sure that your negative monomials are always on the top of your answer, never on the bottom. All right, the last thing I'm going to show you is a question that uses some vocabulary you might not have learned. So I'm going to box this one out to keep things tidy. This is example 5. What I want you to do is draw two triangles that have the same shape, but one of them is bigger. So one small, one big. I don't care what kind of triangles they are, but they should look the same, except one of them is bigger. When you've drawn your triangles, put your labels on it. 3 inches, 12 inches, x, and 18 inches. All right, in your worksheet, it introduces these as similar figures. In English, similar means almost alike, but not quite, or some things match, and that's not entirely wrong. These two triangles have the same angles. So even though one is bigger, if you look at the angles and compare them in the matching vertices, you can see the angles are actually the same. So what is different is that the sides are proportional. And that's a term you might not have come across. A proportion is a relationship in which you have a fraction equaling a fraction, which then gives you something to solve. We will do more with proportions later. This is just a really simple introduction. So to set up a proportion, you want your x to be on top. We have not learned how to solve with x on the bottom yet, so make sure your x is on the top of a fraction, and it's going to be over the corresponding side on the other triangle. So I'm going to have x over 3. Now, if x is on the top, then the other side in the same triangle is also going to be on the top over its corresponding side length. So it's going to be 18 on top over 12. And that is your proportion. I'm not going to go over how to solve this because we did one almost like this in example 4. I will tell you though that when you solve it, you get x equals -8. So this might be a good question to use as a review before the next test. I hope that was helpful. Don't be afraid to review yesterday's notes video if any of this seems unfamiliar. Have a good afternoon.